Hey guys, so the stuff that we have been reviewing for the last couple of days is going to be kind of reviewed in this Unit 4, so it is going to be part of it. But that's stuff that we've already learned prior, so now that we reviewed that, we're going to go over some new information. So this is going to be your Section 1 notes, technically, for Unit 4. And we're going to talk about the development of the periodic table. So a little bit of history. We know now how cool the periodic table is. I was kind of able to show you that when we went over electron configurations, how well arranged it truly is and how well it works out for virtually everything. So you're going to get to see how these men were able to build this incredible chart. So the story begins in the 1700s when a guy named Antoine Lavoisier compiled a list of all the known elements at the time, which at that time there were only 33 known elements. So he just kind of took all the information that was out there and put it into one place. And nothing much changed for quite a while. Those 33 elements were kind of it until the 1800s brought a lot of scientific advancement, technological advancement, and so scientists started discovering more elements at that time, and they needed to try to find a way to organize all of the knowledge that they had gained about elements they knew about before and these new elements. So a scientist named John Newlands started working on it and proposed an arrangement where the elements are going to be put in order by increasing atomic mass. And so when he put together this arrangement by atomic mass, he noticed that the properties of the elements repeated every eighth element. And so if you take a look at my periodic table picture right here on this slide, mostly the elements that they knew in the beginning were the representative elements. And if you don't remember what elements those are, my arrows are pointing to them here. And if you look, the representative elements are eight elements wide. So every time he started off on a new row, the elements started repeating. And he enjoyed music a lot, and since they repeated every eighth element, he kind of went to music for his inspiration and called it the law of octaves. So if you're familiar with music at all, that should kind of ring a bell for you. So unfortunately, this arrangement did not stick because it did not work for all the elements, and his arrangement and law was kind of criticized because he associated it with ideas in music, which is not science, but anyway. What it did do was give other scientists, ones that were going to continue working on this, the idea of repeating properties. So this is where scientists got the word periodic. So periodically, these properties would repeat, so it became known as a periodic trend. So Newlands gave us this word. So once Newlands was kind of discredited for his idea, these two scientists started working on a new arrangement. Lothar Meyer and Dmitri Mendeleev were working on similar things. They had each made a connection between atomic mass and properties of elements. So they are kind of working on the same exact arrangement at the same exact time, but not together. They were working separately, but towards the same goal. So in a way, it was kind of a race to publish. So the winner of that race to publish was actually Dmitri Mendeleev. He is given credit for the very first periodic table. He is known as the father of the periodic table. So he is a major, major name because he published his periodic table before Lothar Meyer. A couple of months before, but it was before. So just kind of by sheer luck, he is known as the father of the periodic table, just because he published before a couple of months before Lothar Meyer. But he does deserve credit because he did come up with an amazing periodic table. So in addition to the table that he came up with, he was also able to predict unknown elements, and he left spaces in his chart where those elements would go. And yes, those elements were discovered, and yes, they belonged in those places on his periodic table. But so that's pretty amazing that he was able to kind of predict the future. However, he was not completely correct in his arrangement. The new elements weren't in the correct order, at least the order that we see them today. So, what I want you to do is pull up a periodic table and see what you notice about elements 27 and 28 and 52 and 53. If you did that, which hopefully you did, you would see that according to those elements I pointed out, that if we were to arrange elements by atomic mass, it would not work because those elements would be out of order from our current periodic table. And our current periodic table is perfect. So that means what Mendeleev was able to put together was incredible, but it is not the modern periodic table that we're used to. We had to have a couple of little fixes in there to make it what you know today. The guy responsible for the modern periodic table, the one that we know and love today, is a man named Henry Moseley. He rearranged Mendeleev's table by increasing atomic number instead of increasing atomic mass. And by doing that, it resulted in a very clear periodic pattern, which we were able to demonstrate when we went over electron configurations. You can see how kind of beautiful it is. And so that periodic repetition of properties of the elements when they are arranged like this, how Moseley arranged it, is called the periodic law. So Henry Moseley is responsible for the chart that we know today. And he has kind of an amazing and sad story. Henry Moseley was an extraordinary person. He was born in 1887, and by the age of 23 had a couple of degrees which earned him a job at the University of Manchester working with a guy named Ernest Rutherford, which you may remember that he actually had a model of the atom. And between 1910 and 1914, he actually won the Nobel Prize for something unrelated to the periodic table, for something in radiation. And then in 1914, World War I strikes Europe, of course. And that same year, he was offered a job at the university, a kind of a promotion. And he could have taken that promotion and been exempt from going to war. But he turned down this job offer and decided to enlist in the British Army because he felt like that was his primary duty, was to serve his nation. So Moseley serves as a technical officer in communications, goes to his first battle, which was in Turkey, and was killed at the age of 27. He was shot in the head by a sniper. And after his death, many main scientists, large personalities of big repute condemned this, that the British Army had allowed him to join. And so this caused the British government to actually place a ban on other scientists of notoriety from serving in frontline roles in the Army. The following year, in 1916, no Nobel Prizes were awarded in physics or chemistry because there is a strong belief that had Henry Moseley been alive, he would have received one of those Nobel Prizes. So Moseley had all these contributions to science before age 27, which is virtually unheard of. If you think about it, every scientist that we ever talk about actually looks like an old dude. So Henry Moseley is kind of an incredible story, but also an incredibly sad story. So not only did he influence science, he actually influenced British law as well. So, final slide here. I just wanted to include kind of a wrap up of all of the major contributions for the major guys that I talked about in this section. So, this is a good kind of wrap up of everything. So make sure that you have taken these notes down and they are going to be ready to use when hopefully we get to return to in-person classes. So I will talk to you guys later. Please keep up to date with your work. Pay attention to due dates. Please, 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 guys.